In this video, I am going to solve the tutorial problem for chapter 15, electric forces and electric fields. Let's start the first question. Find the separation distance between two 1 microcoulomb charges be positioned, making a repulsive force between them is F is equal to 9 Newton. Given that the Coulomb constant is equal to 9 multiplied by 10 power 9 Newton meter square over Coulomb square. So what is given in the question? You have two charges and these two charges are exactly having the same value of 1 microcoulomb, and these two charges are separated with some distance, and the force of repulsive, right, because both are positive charge, that means the repulsive force is mentioned as 9 Newton. So what we are going to do, we are going to find what should be the distance between the two charges. Clear? So that means we are going to find the value of R. So for this question we have to apply the Coulomb's law. So what we studied in the Coulomb's law, the Coulomb's law is given by the rule F is equal to K, the magnitude of the first charge, multiplied by the magnitude of the second charge divided by R square, right? So now we are going to use this rule and we have to rearrange this equation in terms of the distance square, and after that we have to substitute the value of these charges 1 and charges 2 and the force, and finally we will get the answer in terms of distance square, and then we have to take the square root for getting the answer for the distance. Clear? So you have two charges, Q1 and Q2 has the same value as 1 microcoulomb. In terms of coulomb, you have to write 1 multiplied by 10 power minus 6 coulomb. Clear? And what's the repulsive force? The repulsive force they mentioned as 9 Newton. So now what I am going to do, I am going to substitute the value here. So before substitute, first of all, we have to rearrange this equation in terms of distance, right? So what I'm going to do, I'm going to take this R square to the left hand side of the numerator, and by that I have to move this force to the right hand side of the denominator. By that the equation will become R square is equal to the Coulomb constant, the magnitude of the first charge, the magnitude of the second charge over the force, right? Okay, now better I can take the square root because we are going to find the distance only, not distance square. So therefore if you take square root on both left hand side and right hand side, what will happen, you will get the value of the distance R, which is equal to the square root of the Coulomb constant, the magnitude of the first charge, the magnitude of the second charge over the force. Now we have the values here. I'm going to substitute the values here. So R equal to square root of the Coulomb constant value is given, which is a constant. So 9 multiplied by 10 power 9 multiplied by the magnitude of the first charge is 1 multiplied by 10 power minus 6, right? And multiply with again 1 multiplied by 10 power minus 6, because they mentioned both charges having the same value, right? So divided by its repulsive force, they mentioned as 9 Newton, right? So now we have to calculate for getting the value for the distance, right? So I am going to multiply the numerator and then I am going to divide the answer with 9. Clear? So therefore R equal to square root of 9 multiplied by 10 power 9 multiplied by 1 multiplied by 10 power minus 6 multiplied by 1 multiplied by 10 power minus 6 over 9. I got the answer as 0.0316. What's the value? 0.0316, and this is in terms of meter, right? So this is the answer for the first question. Clear? Clear? So it's a direct question. So you have to read the question very carefully. First of all, please try to identify what is given in the question, and after that apply the rule, and please rearrange that equation. So what they need, so you in terms of that you have to rearrange the equation, the main equation, and then substitute the value, get the answer. Clear? So this is the answer for the first question. What answer? We got 0.0316. Clear? Okay. Now we have to move to the second question. Let's start with the second question. What is given in the second question? Consider the 3-point charges Q1 equal to 2 microcoulomb and Q2 equal to -5 microcoulomb and Q3 equal to 8 microcoulomb that are shown in the figure. So figure is given here. You have 3 charges, 2 positive charge they mention in red color and 1 negative charge they mention in blue color, correct? So now what we are going to find, we are going to find what is the resultant force. What is the resultant force exerted on charge 2 by 2 charges Q1 and Q3. So you have to see the figure. We have left hand side and right hand side, we have the charge 1 and 2, both are positive, and the middle charge, so the charges between two positive charge is a negative charge, and you have to identify the distance between the two charges. So please, you have to see here the distance between Q1 and Q2 are very short, right? So that means the force of attraction will be strong, right? So that means this negative charge will move into the left hand side. That means it will take the negative value, right? The answer, the resultant force you are going to calculate must be in negative answer. Why? Because when this negative charge attracted to the positive charge, you have to see the charge 1 and 2 will be separated with a small distance 1 meter. That means the force of attraction will be very stronger, because we studied already in the theory, whenever the distance will be smaller, the force of attraction or force of repulsion will be stronger, right? But if you see the distance between charge 2 and charge 3, so better if you need, better I can enlarge a little bit. By that you can see what is Q1, Q2 and Q3. So if you see the distance between Q2 and Q3, it's a 5 meter. So that means whenever the distance will be more, what will happen? The force of attraction will be weaker, right? Okay, let's see what should be our answer. Okay, so okay, first what we are going to do, I am going to find the force interaction of the charge 2 on 1, and then I'm going to calculate the interaction force between charge 2 and 3, and then I'm going to find the answer, the resultant force. Clear? Okay, let's apply the Coulomb's law for these two charges. What are the two charges? Q1 and Q2, correct? Okay, so I have to apply the rule F of 2, 1. That means the interaction of the second charge on the first charge equal to K magnitude of second charge, magnitude of the first charge over R21 square. So what is this R21? The distance between the second charge and the first charge. Clear? Okay. Now better I can apply the values here. Let's we just find the answer one by one. So the Coulomb constant value is the constant, which is 9 multiplied by 10 power plus 9 multiplied with, what is the value of Q2? The value of Q2 here they mention as -5 microcoulomb, and we are going to take only the magnitude, so better I can write the positive value. So 5 multiplied by 10 power minus 6 multiplied by the magnitude of the first charge. So we have the positive 2 microcoulomb, so 2 multiplied by 10 power minus 6 divided by the distance between charge 2 and 1 is exactly 1 meter, so I have to write 1 square here. Clear? So I'm going to calculate what should be the force. 9 multiplied by 10 power 9 multiplied by 5 10 power minus 6 multiplied by 2 multiplied by 10 power minus 6 over 1 square. I got the answer as 0.144, right? Okay, so this is the answer for the interaction of the second charge in the first charge. Clear? Okay, now we have to find what should be the interaction between, I think is it right, Q2 and Q1. Nine multiplied by 5. So I got 0.09. Sorry. What's the answer here? The answer here is 0.09 Newton. Clear? Okay. Likewise, I'm going to find what should be the interaction between the charge 2 and 3. So let's we apply the Coulomb's law one more time. It is between charge 2 on 3, right? So K, magnitude of the second charge, magnitude of the third charge over the distance between charge 2 and 3. The distance between charge 2 and 3. Clear? Okay, I'm going to substitute the value 9 multiplied by 10 power 9 multiplied by the second charge is minus 5 coulomb. So better we have to take the magnitude. So 5 multiplied by 10 power minus 6 multiply with, I think our third charge is 8 microcoulomb, right? So 8 multiplied by 10 power minus 6 over the distance between charge 2 and 3 is 5 meter. So 5 square. 9 multiplied by 10 power 9 multiplied by 5 10 power minus 6 multiplied by 8 10 power minus 6 over 5 square. I got the answer as 0.0144, right? So this is the answer and the unit is Newton. Now I have to find what is the resultant force. So the resultant force is nothing but this distance minus this distance. By that you will get the answer. So the resultant force equal to, what's the answer? F of 23 minus F of 21, right? So by that the answer becomes 0.0144 minus 0.090, so 0.0144 minus 0.09, I got the answer as 0.0756, 0.0756. So I can write 0.076, and what's the unit? Unit is Newton. And here we have to mention which direction. So actually here the answer is negative, am I right? As I already mentioned, you have to see the figure. So the distance between charge 1 and 2 is only 1 meter. So this negative charge will move to the left hand side. That's the reason our resultant force is negative. Clear? Clear? Okay. So this is the procedure for the second question. Third question. 3 charges are arranged as shown in the figure. So you have to see the figure here. 3 charges are there. Q2 is exactly sitting in the origin, and Q1 is exactly sitting on the x-axis, and Q3 is exactly sitting on the y-axis. And these 3 charges values are mentioned in the figure. And also the distance between the charges Q2 and Q1 is 0.3 meter. Likewise, the distance between charges Q2 and Q3 is exactly 0.1 meter. So we have to take all the data from the figure, okay? And the Coulomb constant is given as 9 multiplied by 10 power 9 meter, Newton, meter square over Coulomb square. So now what we are going to do, we are going to find something. So what is mentioned in the question? 3 charges are arranged as shown in the figure. Find the magnitude and the direction of the electrostatic force on the charge 5 nanocoulomb at the origin. So you have to see the figure here. 5 nanocoulomb is your second charge, right? So that charge is exactly sitting on the origin. So what should be the interaction of this charge? Which charge? The charge 2 on charge 1. Likewise, we have to find what should be the interaction of charge 2 on charge 3. So that means if you want to find the electrostatic force of interaction, we have to use the Coulomb's law, right? The Coulomb's law we are already familiar, am I right? So we are going to apply this, and we are going to find the magnitude and the direction by using this interaction. Clear? Okay, let's start with the Coulomb's law. What is the Coulomb's law for the first charge? So I am going to apply the Coulomb's law for charge 2 and charge 1. So F of 2 on 1. Clear? F of 2 on 1. K is the Coulomb constant. the magnitude of the second charge, the magnitude of the first charge over the distance between charge 2 and 3 is mentioned as R of 2 1 square. Clear? So I'm going to substitute the value. The Coulomb constant is 9 multiplied by 10 power 9 multiplied by, I'm going to take the magnitude of the second charge, which is 5 nanocoulomb. So 5 multiplied by 10 power minus 9 multiplied with the first charge. What is the first charge? 6 nanocoulomb. So 6 multiplied by 10 power minus 9 over the distance between the charge 2 and 6. Sorry, charge 2 and charge 1 is exactly 0.3 meters. So the distance is 0.3 meter. So I have to square this. So I'm going to find what is the force. 9 multiplied by 10 power 9 multiplied by 5 10 power minus 9 multiplied by 6 multiplied by 10 power minus 9 over 0.3 square. What's the answer? I got 3 multiplied by 10 power minus 6 Newton. And likewise, I have to find the interaction between charge 2 and 3. So F of 2 and 3 gives K magnitude of the second charge multiplied by magnitude of the third charge over the distance R of 2 and 3 square. Clear? So here 2 3 is nothing but the distance. Okay, so don't get confused. I have to apply the value 9 multiplied by 10 power plus 9 multiply with Q2. What is the Q2? 5 nanocoulomb. 5 multiplied by 10 power minus 9 multiply by, and Q3 here is minus 3 nanocoulomb, but we are going to take only the magnitude value. So it is 3 multiplied by 10 power minus 9 over the distance between these two charges is 0.1 meter. Clear? Okay. Sorry, square. I have to square this also, right? Let's see what is the answer for F of 2 3. 9 10 power 9 multiplied by 5 10 power minus 9 multiplied by 3 10 power minus 9 over 0.1 square. I got 1.35 multiply 10 power minus 5. Okay. Now we are going to find its magnitude. How to find the magnitude? Let's see the figure one more time. We have to see here. Actually, what will happen? This is positive, this is positive. So positive and positive charge, what will happen? It will repel each other. So that means the repulsive force will be coming here. So which is nothing but the repulsive force of F of 2 3. So 2 and 1, right? Likewise, this charge 2 and 3, what will happen? It will attract, correct? Am I right? Okay. Now, if you want to take the magnitude, this is your x component value, and this is your y component value, which is f of 2 of 3. This is your y component, and we already have the x component value and y component value. We can directly find the magnitude. How to find the magnitude? We already studied the magnitude in chapter number 3, vector, right? So magnitude is equal to the square root of x component. What is your x component? F of 2 1 square plus my y component is f of 2 of 3 square. I'm going to substitute the value. My x component is 3 multiplied by 10 power minus 6, right? And here 1.35. So I have to substitute the value. Square root of 3 multiplied by 10 power minus 6 square plus 1.35 multiplied by 10 power minus 6 square. So I'm going to find the answer for the magnitude. Square root of 3 multiplied by 10 power minus 6 square plus 1.35 10 power minus 6 square. Sorry, one more time. 3 10 power minus 6 square plus 1.35 10 power minus 6 square. I got, what's this answer? I think I did not calculate properly, right? Okay, I will do it one more time. 3 10 power minus 6 square plus 1.35 10 power minus 6, so minus 5, oh sorry, 10 power minus 5 square. Yeah, I got the answer as 1.38 multiplied by 10 power, this is not 6, actually this is 5, huh? But I can go back, you can see this is 10 power minus 5. Actually, initially I used 10 power minus 6, that's the reason I got different answer. So 1.38 multiplied by 10 power minus 5 Newton. This is our magnitude value. Now we have to identify what is the direction. As we already studied the same formula in chapter number 3, vector theta, which is equal to tan inverse of y over x. So what is your y here? F of 2 3 is your y and x is f of 2 1 is our x. So tan inverse of the value of f of 2 3 is 1.35 multiplied by 10 power minus 5 over 3 multiplied by 10 power minus 6. So what will be the answer? Tan inverse of 1.35 10 power minus 5 over 3 multiplied by 10 power minus 6. It's exactly 77.47. So I can write the theta angle as 77.5 degree. So which quadrant this angle is exactly lies? You have to see, actually here we have 3 quadrants, am I right? If you see the figure, if you see the complete, so this is your first quadrant, this is your second quadrant, this is your third quadrant, this is the fourth quadrant, am I right? So that means your answer lies in third quadrant. So how to find the third quadrant value? Just add 180 with this number, so you will get the answer. Or if you don't need, just leave the number, at least mention the quadrant place. So which quadrant? The answer, the angle is exactly in third quadrant. Clear? Clear? So if you want, you can write in terms of 360 degree. If you want, you have to write up to second quadrant. We will get the answer up to 180. So 180 plus this number 77.5, we got maybe approximately close to 257.5 you will get. Clear? Or you can leave as it is, just mention the quadrant place. Okay, that's it. Now we have to go to the fourth question. Okay, read the question. 3-point charges are located at the corner of an equilateral triangle as shown in the figure. So you have to see the figure. It's exactly looks like an equilateral triangle. What is the beauty of the equilateral triangle? All side angles are exactly the same. That means here we mentioned, they mentioned 60 degree, am I right? So this angle is also 60 degree. This angle is also 60 degree, and the sides are the same value. Clear? So they said 3 charges exactly sitting in the form of an equilateral triangle. Again, we are going to calculate what is the magnitude and direction of the net electric force. So we are going to find what is the net electric force. So it's again, so we have to see what is the electrostatic force of attraction, what is the electrostatic force of repulsion. So we are going to identify. In that way, we are going to find the magnitude as well as the direction. Clear? Okay, first of all. And what they mentioned, you have to take some reference. What they mentioned in the question, find the magnitude and the direction of the electric force on 4 microcoulomb charge. So where is the 4 microcoulomb charge? Actually, they mentioned the third charge is the 4 microcoulomb. Am I right? So we have to take this as our reference charge. So the charge exactly sitting on the origin. Clear? So what should be the interaction of the third charge and the second charge? And what should be the interaction of third charge and the first charge? So first of all, let's start with the charge between the 2 and 3. Clear? Coulomb's law, F of 3 of 2, k magnitude of 3 magnitude of 2 over the distance between these charge exactly, because I told you all sides are same, am I right? So 0.3. So here if it is 0.3 means here also 0.3, here also you have 0.3, right? So better I can write the value here for this. So 0.3 square, I'm going to substitute the value 9 multiplied by 10 power 9 multiplied by the magnitude of the third charge is 4 microcoulomb. So 4 multiplied by 10 power minus 6 multiplied by the magnitude of the second charge is 9 microcoulomb. 9 multiplied by 10 power minus 6 over 0.3 square. So let's see what is the answer. So the answer is 9 10 power 9 multiplied by 4 10 power minus 6 multiplied by 9 10 power minus 6 over 0.3 square. I got the answer as 3.6, right? Yes, it's 3.6 Newton. Likewise, I have to find what is the electrostatic force between charge 3 as well as 1. Clear? Okay. F of 3 on 1, k magnitude of 3 magnitude of the first charge over, again the distance is 0.3 square. I'm going to substitute the value 9 multiplied by 10 power 10 power plus 9 multiplied with the third charge is 4 microcoulomb. So 4 multiplied by 10 power minus 6, and the first charge is minus 6 microcoulomb. So we are going to take the magnitude only. So 6 multiplied by 10 power minus 6 over the distance is 0.3 square. Let's see what is the answer for this f of 3 1. 9 10 power 9 multiplied by 4 10 power minus 6 multiplied by 6 10 power minus 6 over 0.3 square. I got the answer as 2.4. What's the answer? 2.4 Newton. Clear? Okay. Now we have to identify the magnitude, am I right? So for calculating the magnitude, you need what is your x component and what is your y component, right? So for that, we have to see the figure. Actually, I have to draw the figure one more time for showing the direction of the forces, right? Actually, we have like this and 3 charges. This is charge 3. This one is charge 1, and we have another charge 2, right? So it's exactly looks like an equilateral triangle, am I right? And we show the x-axis and y-axis here. Now we have to identify what should be the x component. Brother, listen carefully. Here, this third charge is a positive, right? And this second charge is also positive. We have to go back and see the figure. Clear? See, both red color are positive and this blue color is a negative. So that means only the negative charge is the first charge, right? So what will happen? The positive and positive will repel, right? So that means it will come in this direction, right? So this is our f of 3 of 2, right? Okay. Likewise, you have to see the direction. The 3 and 1, what will happen? It will attract. Understand? Now, the most important thing, better I can change the color. That will be give a clear idea, right? Okay, see here. So this is our repulsive force. This is our attractive force. Am I right? So this indicates f of 3 of 1. This indicates f of 3 of 2, right? And you have to see this f of 3 of 1 is exactly sitting on the x-axis, so no need to, because we are not going to get any x component and y component. We are getting exactly the answer which is exactly in x-axis. But if you see f of 3 of 2, it lies between two lines, am I right? So we will get the x component as well as the y component, right? Am I right or not? So we have to take this. Understand? The most important thing, it's very, very important. We have to see the direction. Now, for getting the value of x component. So I'm going to change the color. So what is our x component? The x component f of x, which is exactly equal to Right side force, left side force. What is your left side force? This one is F of 3 of 2 x component. Am I right? F of 3 of 2 x component, and this one is F of 3 of 2 y component. Right? Am I right or not? So this value f of 3 1 minus f of 3 of 2 x, both having the x component force. Am I right? So how I can write for finding the x component force, how I can find f of 3 of 1 minus f of 3 of 2 x component. What is x component? As we already know, f of 3 of 1 I can write as it is minus, how we can write this one? We have to find the cosine. Am I right? So that means f of 3 of 2 cosine of theta. And we know what is the value of f of 3 1. What is the value of f of 3 1? Which is 2.4, right? So 2.4 minus, and what is the value of f of 3 of 2? F of 3 of 2 is 3.6, right? 3.6 cosine of, and this is an equilateral triangle, all angles are 60 degree, so 60 degree, and when you calculate you will get the x component value. So let's see what's the answer. So 2.4, this is not 24, this is 2.4, right? So 2.4 minus 3.6 cosine of 60 degree. So I got 0.6. What's the value? 0.6 Newton. And likewise we have to find the f of y. What is f of y? We have only one f of y. Am I right? There is no another force. So better I can take the value of exactly, but this is in the negative direction. So I have to take f of y, f of 3 of 2y. Am I right? So f of 3 of 2 of y component, but this is in the negative of y axis. So I have to put minus. So f of 3 of 2 is 3.6 value, right? So minus 3.6 Newton. So once you identified what is your x component and y component, we can directly go for the magnitude. So how to find the magnitude? The magnitude is equal to square root of f of x square plus f of y square. So f of x square just before we found as 0.6 square plus f of y is minus of 3.6 square. So let's see what is the magnitude value. Square root of 0.6 square plus minus 3.6 square. I got the answer as 3.65. What's the answer? 3.65 I got. 0.6 square is minus. This is not this actually. This is y component. Am I right? Oh, I just made a small mistake. Oh, this is not exactly the same value. What is the value? Y component minus of 3.6. What is your y component? Actually, this is your x component means cosine. Y component is sine. Am I right? So 3.6 sine of 60 degree. So better I can erase this. I can erase this part. Clear? Now I have to find this value. Minus 3.6 sine of 60 degree. I got 3.12, sorry, minus 3.12 Newton. Now I have to substitute our x component. X component is 0.6 square plus minus of 3.12 the whole square, which is equal to 0.06 square plus 3.12 square, 3.18. What's the answer? 3.18 is our magnitude. Clear? Okay, now we have to find the angle also. The angle formula we know, theta equal to tan inverse of f of y over f of x. F of y value is minus 3.12 Newton, right? Over the x component value is 0.6 Newton, 0.6 Newton. So what's the answer? Tan inverse of minus 3.12 over 0.6. We got minus 79. What's the answer? Minus 79.11 and degree, right? So now we have to tell, which quadrant. If you see this diagram, this minus will come here. Am I right? Am I right? Because if you see, all these three charges are exactly sitting here, and we got negative of 77. It's not positive, it's negative. So it's exactly lies in fourth quadrant. If you want to give the answer in terms of 360, it's simple. Just 360 minus this number, you will get the answer. Or otherwise, you can just leave as it is, as minus 79.11 square 11 degree. So, but mention it is in fourth quadrant. Clear? Understand? That's it. Okay.